All right, so you were answering the questions, ladies and gents. You're answering the questions to 1, 2, 3, and 4. Let's go. 1, 2, 3, and 4. So for some people, this is actually a weird concept to try to see what's an opposite side. So they're asking, does a pentagon have opposite sides? So draw yourself a little pentagon. Doesn't have to be regular, but there's your pentagon. And then if I were to draw an arrow from here to here, yeah, I can get an opposite side there, right? But here, what's the opposite side to this one? Is it here or is it here? Is it here or is it here? That's hard to tell. So there isn't just one opposite side to each side in a pentagon. And so the answer is no. And then the question begs, does an engon, so whatever side polygon, have opposite sides if n is an odd number, so like a septagon, a notagon, and you're going to run into the same problem. And so your answer should be no. So then notice that in 3 and 4, they give you a quadrilateral, which has an even number of sides, and this was kind of a no-brainer because they probably weren't going to go straight across, just saying. But if you go straight across here, there's your opposite side, and straight across here, there's your opposite side. So this entire section is proving that a quadrilateral is a parallelogram. So we're still working with all the parallelogram characteristics and the definition that we had in 6-2. But now you have to prove that what you're given is a parallelogram. So let's look at our definition of the parallelogram again. This is your formal definition. A parallelogram is a quadrilateral with two pairs of opposite sides parallel. And so that's what we stated the other day. Opposite sides may include arrows to show the sides are parallel, and that's what they're inferring here. Over here. So you're looking for those arrows. So, each set of parallel lines has, it's like tick marks. So the one set of arrows, those are the ones that are parallel. The two sets of arrows refer to those being parallel. So they're trying to tell you something using that. Write P for questions 5 through 7. Write P if the statement describes a parallelogram, or NP if it does not. P if you think it could be a parallelogram, or NP if it's not. What would be a parallelogram out of those? An octagon, 5 congruent sides, or a regular quadrilateral? What do you think about an octagon? Does it have 2 pairs of opposite sides that are parallel? An octagon, if it's a regular octagon, it would have 4 pairs of opposite sides parallel, right? So although if it's a regular octagon, that would occur, it doesn't match the definition of a parallelogram because it's more than 2 pairs of opposite sides. So an octagon would be NP. Yes. Only 2 pairs. And so that's that key phrase in there with 2 pairs. And remember, geometry is very picky, very particular. What about 5 congruent sides? What kind of a figure is that? 5 congruent sides, what kind of figure? A pentagon. Okay, a pentagon. So you could end up with one pair of parallel sides to that. Maybe you have 3 sides that are not parallel, just by nature of that, because it's an odd. So that's an indicator. So 7 is the only one that is a parallelogram. What kind of a parallelogram would be a regular quadrilateral? Meaning all sides are equal and all interior angles are equal. A square. So on 8, 9, and 10, I want you to write P if the figure appears to be a parallelogram and P if it does not. What do you think about 8? Yes or no? Yes. What about 9? No. And what about 10? Yes. Now I'm going to stop you here, and you cannot look at a picture and make assumptions, by the way, in this chapter. So unless you are led to believe via the characteristics of a parallelogram, you cannot assume. So you're going to look at a whole bunch of theorems. You're going to notice something about them. Note what the theorems say. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. If an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. And notice that it says both pairs, not just one pair, but both pairs. And on this one it says both of its consecutive angles. Those are key things. On this one, both pairs. This one says if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. If one pair, this one's interesting, this one's actually new. If one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So aside from 612, what do you notice about theorems 6.8 through 6.11? Aren't they the converse of all the theorems that you had in 6-2? So don't you already know that? They're just the converses. And you're right, Bailey, that they are the characteristics of a parallelogram. So we're going to use our knowledge of the characteristics and the definition of a parallelogram in order to determine if a quadrilateral is a parallelogram. And only quadrilaterals can be parallelograms. This one, however, is new. And what this one is saying, so draw a picture over here. And let's think about this logically. What this is saying is that one pair, just one pair, of opposite sides are both congruent and parallel. So I'm going to put a congruent marker here, and then I'm going to put a parallel angle marker here. If these are parallel and they're the same size, it doesn't matter where I put these to each other. The distance from here to here is automatically going to end up being congruent, and automatically they're going to end up being parallel. It's impossible for them not to be. The minute that you have one set of sides that are both parallel and congruent, the other two sides have to fall into place. So all you have to do is prove that, and you prove that you have a parallelogram. So that one is new. So that one you need to put on the flashcard. And so add that to your characteristics up there. That we put on a separate piece of paper yesterday. So we now have a 6th characteristic, because I include the definition as one of their characteristics. So there's 6 things that you're supposed to know about a parallelogram. So then, looking at the diagram at the right, we're going to fill in the things that we should know based on those things. So if side AB is congruent to side what? CD, and side BC is congruent to side AB, then ABCD is a parallelogram. Then they go on here to say that the measure of angle A, so this whole angle here, measure of angle A plus the measure of angle B is equal to what? 180 degrees, and the measure of angle blank and D equals 180. Which one would that be? Not C. Because I want one angle has to be supplementary to both of its consecutive angles. So this is the angle that's supplementary to these two right here. So we're talking about A and D. So I want angle A. And yes, C would be supplementary to D, but according to the theorem, this has to be supplementary to the two angles on either side of it. And those angles happen to be opposite angles, which means they're congruent. Then 13, if angle A is congruent to blank and angle blank is congruent to angle D. So if angle A is congruent to what? C. So we know that A would be congruent to C. And what is congruent to D? B. So you have your opposite pairs of angles are congruent. Here's a parallelogram. Here's segment AE. Oh, guess what E would be? Add an E in there, please. So segment AE is congruent to what? CE. Segment CE. And segment BE is congruent to segment ED. Then we have a parallelogram. Here's segment BC. That's this side here. I'm not going to take my first, but if this side is congruent to this side, which would be AD, and BC is parallel to that. BC is congruent to this side and parallel to that same side, so it has to be AD. But you have one set of opposite sides that are both congruent and parallel, then you have a parallelogram. And then if side CD is congruent to what? What would it be congruent to? BA. And CD would be parallel to what? BA. And then you've also have a parallelogram. Alright, so let's look at some problems. Use the diagram at the right for what values of x and y must E, F, G, and H be a parallelogram. So you're using your knowledge to decide what would x and y have to be for that to be a parallelogram. Well, they're giving you angle measures in here, aren't they? So can't I set these two equal to each other? So isn't that this one? And then couldn't I set these two equal to each other? The 3y minus 2 and the 12x plus 7. That's not one of these here, is it? So we could do that. I'm going to put that up here to the side. 3y minus 2 equals 12x plus 7. What's wrong with that one? What's wrong with both of these? Equation with two unknowns, right? So then, remember that we also have consecutive angles are what? Supplementary. So I could add these together and set them equal to 180. Add these, set them equal to 180, or these, or these. And so look what they've done here. Y plus 10 would be this one. And then are these two, like the 3y minus 2 is this one, are these two consecutive? True or false? Yep. So then that would be a viable equation. Can you take y plus 10 and set it equal to 3y minus 2? Can you set those two equal to each other? No. So that one's not a possibility. So out of those three that we've looked at so far, which one could we use right away? This is the only one that has one unknown, right? So we're going to use that one. So we're going to find y first. We're going to take the y plus 10 plus the 3y minus 2 equals 180. You want to collect your like terms. So your y's will give you 4y. Your constants will will give you positive 8 equals 180. Do not lose your equal sign. Don't drop it out. You get 4y is equal to 172 divided by 4. And so y is equal to, and then find x. They only want x now, right? So to find x, I can use either of these two equations to find x. Which would you prefer? Well, it doesn't matter. We'll use this one. So y plus 10 is equal to 4 times instead of x. Oh, never mind. I got wrong. I'm going to replace y. So instead of y, I'm going to replace that with 43. And I'm for x plus 13. So 43 and 10 is 53. Subtract your 13. You get 40. What does x equal? 10. So basically they're asking you what does x and y have to be. For that to be a parallelogram, they have to be, x has to be 10, y would have to be 43. Otherwise it's not a parallelogram. So is it a whole lot different than what we were doing yesterday? You're just making some different assumptions. That's all. Really doing the same thing. And then problem 2, can you prove that the quadrilateral is a parallelogram based on the given information? So let's just look at the picture, ignore all this. Let's just look at the picture. They've given you what here? One set of parallel sides and one set of congruent sides. Is there any theorem that says that if you have one pair of sides that are parallel and one pair of sides that are congruent, that you have a parallelogram? One set, or is it the same set has to be congruent and parallel? Technically, I cannot prove that, right? I could take this and these are not congruent, so I could actually technically extend out this line to right here. Although then that wouldn't fit with it. But based upon our current theorems, do we have any theorem over here that states one pair of sides is parallel and one, the second pair, the opposite pair, is congruent? Is that one of those theorems that? Yes or no? Which one? Just push your knob your head. Which one? Are you saying it's this one? Well, okay, so let's look at this. It says on theorem 6a, both pairs of opposite sides are congruent. Did they label both pairs of opposite sides congruent? No. And then this one says that both pairs, our definition says what? Our definition says that both pairs of opposite sides are parallel. So that's what our definition says. And we only have one pair. This one here, 612, says that one pair of opposite sides is both congruent and parallel. We don't have that. So therefore, no, there's not enough information. You would need to either have these sides being congruent or these two sides being parallel. All right, so let's look at problem 3. A truck sits on the platform of a vehicle lift. 2 moving arms raise the platform. What is the maximum height that the vehicle lift and elevate the truck and explain? That's a toughie. What's the maximum height? 6 feet. That's going to be 6 feet, isn't it? Right? Because this is going to represent the height. And it can only get up to 6 feet. That's it. The maximum height. The hard part is finding why. is 6 feet because that is the length of the distance between the parallel sides that are 26 feet long. That's how I would explain it. Those are those questions that you guys have trouble with. You're like, well, yeah, duh, it has to be. Or what? Think outside the box. Okay. Last problem, lesson check. How is theorem 611 in this lesson different from theorem 6.6 in the previous lesson? So theorem 6.6 says if the quadrilaterals are parallelogram, then the diagonals bisect each other. Whereas 6.11 says if the diagonals of a quadrilateral bisect each other, then the quadrilaterals are parallelogram. It's not a biconditional, this isn't heavy if and only if, but they are converses of each other, right? So these two are converses, and they assume different things. On this one assumes that you have a parallelogram. So if my assumption is I have a parallelogram, my conclusion is that the diagonals bisect each other. Whereas on this one, my assumption is that the diagonals bisect each other. That's my known fact. Then my conclusion would be, oh, well, it must be a parallelogram. So that's what the converse is doing. You have a different fact that you're basing your conclusion on. (32 and 33). A quadrilateral is a parallelogram. Which one or which ones can you use for that one? Can I determine that this is a parallelogram based upon the markings on here? What are the markings telling me? That the diagonals bisect each other. If your conclusion is, or if your assumption is that the diagonals bisect each other, what can your conclusion be? That the quadrilateral is a parallelogram. So from here to here, I can conclude that. But what about this one? What's this one telling me? Just with the markings, what's that telling me? What are these telling me? What are those telling me? What are parallel? To be specific. Opposite sides are parallel. Can I conclude that it's a parallelogram when opposite sides are parallel? Isn't that the definition of a parallelogram? So my conclusion is yes. I can conclude that with that as well. The second question says the diagonals of a quadrilateral bisect each other. Can I conclude that with this one? Isn't that what we said? So this one works with that one as well. Can I conclude this on this one? Immediately? No. I can get there by saying, oh, okay, if opposite sides are parallel, then it's a parallelogram. If it's a parallelogram, then the diagonals of the quadrilateral bisect each other. So I can get to it, but not an immediate termination. But yeah, eventually I would say, okay, yeah, the diagonals here bisect each other too. So we already talked about this as a converse. And we don't need to do 35. We already talked about that. All right, so we're done.